Chemistry.
Beautiful, beautiful. What other thing did we treat in the previous class that you can remember?
Uh, I don't know.
Are you sure? Do you remember that we treated some of the aspects that chemistry applies to in our daily life? Do you remember that?
Yes.
Aha, I got you there. All right, so today we're going to be treating, do you know the topic we're going to be treating?
No.
I sent the material already to the class, but that's not a problem. Today we're going to be treating the particulate nature of matter. The particulate
Oh,
nature of matter. You can see it on the screen right now. Is that correct?
yes.
Can you see it on the screen?
It's loading.
Okay. Particulate nature of matter is what we're going to be treating. All right. You should be able to see it right now. Can you see it now?
Yes, sir.
Beautiful. So I have some objectives that you should be able to achieve at the end of today's class. Can you help me read them out, please? From number one to number four.
Define and distinguish between atoms, molecules, and ion.
Okay.
Explain the concept of particulate nature of matter.
Beautiful.
State the main postulates of kinetic theory of matter.
Beautiful.
And describe the state of matter, bracket, solid, liquid, gas, and plasma, in terms of particulate arrangement, motion, and energy.
Beautiful. So this class now has been divided into two sections, okay? The first section is going to be taken today. The next section is going to be taken on Monday. So by way of introduction, you know what matter is that correct?
Yes, sir.
Good. I already have the definition on the screen. Matter is anything that has two things. Number one, mass. And when we say mass, we are simply talking about how heavy or light an object is. Is that correct?
Yes, sir.
Good. You can see the things that I'm writing on the screen. Is that correct?
Yes, sir.
Good. So can you give me some examples of matter that you know?
Oh, chairs,
Chairs, very
tables,
good table,
pencils,
very good pencil.
the
How
phone I'm
about
using.
good, the phone you're using to watch this is also matter. How about the air you're breathing in and breathing out? Is that also matter?
Yes.
Good, because it has mass and occupies space. So I brought in that question to test your ingenuity and you passed beautifully well. So the air we breathe, the food we eat, even the clothes we wear can all be classified as matter. So that brings us to the next thing. We want to know what matter is really made up of. You see, matter doesn't just appear on its own. There are certain little particles that you may not be able to see that make them up. And that's why we're talking about the particulate nature of matter today. And those particles are subdivided into three. We have the atoms, we have the molecules, and then we have the ions. In today's class, we're going to be looking at the atoms, and we're going to also looking at the molecules. Are you with me?
Yes, sir.
Beautiful. Now, one thing about these particles you must know is that they are always in constant motion and are held together by different kind of forces depending on the state of matter. Now, you can see this image here. What does this image tell you, David? Can you explain to me?
Uh, that water has molecules.
Very good. In other words, this cup of water over
Yeah.
here, when you use maybe a microscope or a magnifying glass, you would see that it is made up of teensy tiny molecules that you may not be able to see with your naked eye. And the same thing applies to other states of matter. That brings us to talking about the characteristics of matter that we have. Can you see what's on the screen right now?
Yes.
Beautiful. So, what are some of the characteristics of matter that we have? Characteristic number one says that matter is made up of tiny separate particles or discrete particles. And then the second
Okay.
characteristic of matter is that these particles are always in motion. You can see this illustration that I have on this part of the screen. Can you see it?
Yes, sir.
All right, let me load it one more time. You can see that the particles are moving. For the liquid over here, you can see the particles are moving. And for the
Yes,
solid,
sir.
good. For the gas, you can see the particles are moving faster than for the liquid. And then for the solid, you
Yeah.
can see the particles are stuck on one position.
Yes, sir.
Good. That brings us to the next characteristic of matter. There are spaces between the particles that make up matter. For instance, at the
Mm.
part of the solid, you can see that the spaces between the particles are very small. Is that correct?
Yes, sir.
Good. And for the particles for the liquid, the spaces are bigger than the ones for the solid. And then for the one for the
Yeah.
gas, the spaces are the most or are the largest.
Oh, yes, sir.
Very good. And that brings us to the final characteristics of matter that we have. We have plenty more, but we're just looking at four. The particles that make up matter attract each other with varying strength depending on the state. So the forces of attraction between the particles in a solid is greater than the forces of attraction than the particles in a liquid, and the particles in a gas has the least force of attraction. That is why if I put solid S, liquid L, and gas side by side, and I ask you, David, which one is going to be the easiest to break among the three of them or to separate among the three of them? Which one would you say?
Gas.
Thank you very much. Because the forces of
Gas.
attraction, yes, the forces of attraction between the gas state of matter is very, very weak. And then the one that is going to be more harder to break will be the liquid. And then the hardest to break will be the solid. Are you understanding what's going on in today's class?
Yes, sir.
Beautiful, beautiful. So that brings us to the next thing that we want to talk about. Those particles that make up matter. And the first of them all is atoms. We want to talk about atoms. So in the last class, did we say anything about what an atom is?
Yes.
Okay, what's an atom?
An atom is the smallest particle of an element that can that can take part in any chemical reaction and still retain its former form.
Beautiful, beautiful, beautiful. See that? Counseling, counseling. You want to say?
Uh,
Great. Beautiful. I like how you said that. An atom is the smallest particle of an element that can take part in a chemical reaction and still retain the properties of that element. You know the way when you want to build a house, what you're going to use are blocks, or those in outside country will call it bricks. Are you with me? Hello, David, are you there? Hello, David, can you hear me? Hello, David.
come on, yes, sir. Yes, sir. Yes, sir. Hmm.
Hello, David, can you hear me now?
Yes, sir.
All right, beautiful. So, the last part where we stopped was the atom. We're talking about
Yes.
what the atom is. So we started off by saying the atom is the smallest particle of an element that can take part in a chemical reaction and still retain the properties of that element. And then I was giving an example before the network went off. I said, when you're building a house, for instance, just like when you want to build a house, the materials you use for building are called blocks or bricks. Is that correct?
Yes, sir.
Good. When matter is to be built up, the building blocks that are used to make up matter is what is known as atoms. So we have
Okay,
trillions
sir.
and yes, trillions and trillions of atoms coming together to make up every form of matter you can see and interact with today. So now, even though atoms are extremely small, scientists have been able to discover their structure. You know what structure is, right?
Yes, sir.
Beautiful. What structure? What is the meaning of that word structure?
The structure is like how we like I'm not using a building as an example. Like
Okay.
how you want to hear it look. What shape would it be in? How do you want it to look? That's what the
Thank you.
structure.
Thank you. Thank you. Structure simply talks about the physical presentation of something, how something looks like. Now, this is just an illustration of what an atom looks like. You can see some yellow stuff moving in circles round about a big ball containing small, small spheres. Is that correct?
Yes, sir.
Good. Those yellow circles, there is a name that we call them in chemistry. Now, these big balls that are in a circle over here, it contains some things, and there are certain names that we call them too. And that is what we're going to look at in the next section, the things that make up an atom. So, number one is the nucleus. And the nucleus talks about the central part of the atom. If you look at this diagram that I have over here, you will see there is a part in the center, this part over here. Did you see that?
Yes,
Very
yes,
good.
sir.
The nucleus is the central part or the center part of the atom, and there are certain things that are contained inside. There is the proton, and then there is the neutrons, or there are the neutrons rather. And in our last class, I don't know if it was in our last class that I said it, I talked about what the proton is. Did I?
Yes, sir.
Okay, good. What's the proton?
Proton is the positive
Hmm,
charge in atom.
no,
And
the positively charged subatomic particle.
atomic particle.
Subatomic particle. Say it.
Subatomic particle.
Good. So the positively charged subatomic particle is what is called the proton. And then the neutron is the subatomic particle that has no charge. Did you remember that?
Yes, sir.
Good. In other words, the charge is zero. And then the final one is the electron. The electron is the atomic particle that has a negative charge. Did you remember that?
Yes, sir.
Okay, so the center part of the atom is called the nucleus. And that is the part that contains the protons and the neutrons. The electrons, however, are not contained in the nucleus. They are contained in or around the nucleus in a location that is known as energy levels or shells. If you watch very closely, you can see some circles round like
Yes,
this
sir.
that are containing some red balls around it. Is that correct?
Yes, sir.
Good. Those red balls around it are called the electrons. And then the circular path that they are moving around is what we call electron shell or energy level. Are you there?
Yes, sir.
Good. So the electron cloud or shells is the region that is around the nucleus. So if this is the nucleus, for instance, this center point, then the shell is going to be around it. The electrons are the ones that reside on the shells. Did you see the illustration?
Yes, sir.
Beautiful. So the next thing about electrons is that they move very fast around the nucleus in parts called shells or energy levels. In those diagrams that I showed you in the preceding slides, you see the electrons moving very fast. In this one, so you see the
Yes.
electrons moving very, very fast. Can you see it?
Yes.
Good. So in summary, Protons and neutrons are in the nucleus, while electrons move all around it. You can see that illustration being shown perfectly here.
Yes, sir.
Good. At this point, do you have any questions to ask?
Okay. You said molecules are always in motion in solid, liquid, and gas, but in the diagram, we not see the solid, we not see the molecules in solid moving. Why?
Okay, let me go back. Let me go back. Now, we said that these particles that make up the solid and the liquid are always in motion. You remember that, right?
Yes, sir.
Very good. Now, let's define that word, motion. When we say something is in motion, what do we mean?
It's moving.
Good. We mean it is moving or it is changing position. You can see here in the gas particles, the movements are very, very vivid. You can see them easily. Over here in the
Yes,
liquid
sir.
particle, the movement is very, very vivid as well. You can see them easily. However,
Yes, sir.
in the solid, the kind of motion that is going on there is something that is called the vibrational motion.
Okay.
Good. Vibrational motion simply means that they are
Yes, sir.
vibrating around a fixed point. And that is why you did not necessarily see the movement over here because the particles
Mm,
are so tightly packed together that the only space that they have for motion is the vibrational kind of motion. They are vibrating in one point. They are not moving necessarily from one point to the other, maybe point A to point B. They are just in one point vibrating. Did you get
yes,
that?
sir.
Good.
Yes, sir.
That is why when you place a solid on one point, it just remains there. The particles inside it are only vibrating. That is the kind of motion they are undergoing. Did you understand my explanation?
Mm, yes, sir.
Are you confused?
No.
Are you sure?
Yes, sir. No.
If there is anything you do not understand, don't hesitate to draw me back, okay?
Okay.
Okay, somebody just joined our class. Who was the person? Let me see. Not that- Hello, you're welcome. Can you hear us? Unmute yourself and say hello to the class.
Hello, sir.
You're welcome. How are you today?
Fine, sir.
Has it been long you joined today's class?
No, just 7 minutes ago.
Oh, beautiful, beautiful. And how have you been catching up with what we're treating today?
Ah, mm, fine.
Don't worry, okay? I'm going to be posting the recording for today's class on my YouTube channel, and then I'll drop the link in the group so you'll be able to watch it. All the parts that you missed out, you catch up with it, okay?
Okay, sir.
All right. So can we proceed?
Yes, sir.
Yes, sir.
All right, let's proceed. So now we've talked about the atoms and we've talked about the stuff that makes up the atom. David, can you refresh our memory one moment and tell us the things that make up an atom?
Uh, protons,
Mm-hmm.
neutrons,
Mm-hmm.
and electrons.
Good. The part that has the neutrons and the proton, what is that part called?
Okay. Nucleus.
Thank you very much. The part that has the electrons, what is that part called?
Shell.
Good. It is called the electron shell or energy level. Now, how did we even come to discover about this atom? That is what we want to talk about up next, the historical background of how scientists came to know about what atoms are. And that brings us to the John Dalton's atomic theory. Have you ever heard this phrase before, John Dalton's atomic theory?
Yes.
Good.
A little.
Okay, maybe not in depth, right? So we're going to be going deeper into that theory today. In the year 1803, how many of you were born that time?
No.
I mean, I was born that time. Oh. In the year 1803, I'm just kidding. John Dalton, a scientist just like you and me, proposed something called the first modern idea of atoms, known as the Dalton's atomic theory. His ideas were the ones that laid the foundation for chemistry. This is his picture. This is what he looks like, or he looked like rather. Okay, so he proposed an idea. That idea was called the Daltonic atomic theory. What did that theory say? The theory proposed a number of things. And number one, that theory said all forms of matter are made up of very tiny particles called atoms. And you can see those
Yes.
particles over here moving in different directions. And then the
Yes.
second idea stated that atoms are indivisible. Do you know the meaning of that word, indivisible?
Um, yeah, I think.
Yes,
No,
sir.
sir.
Okay, what's the meaning of that word, indivisible?
It can be broken down
Thank
into
you,
smaller
thank you,
particles.
thank you very much. Another word for indivisible is undividable. Cannot be divided into smaller particles. Is that correct?
Yes, sir.
Good. For instance, if you are eating corn, you know corn, right?
Yes, sir.
Good. And you're eating a corn, and then maybe your junior brother comes and asks you for a piece. You can break it into two. If people keep coming to ask you and you keep breaking it, a time will come when you will not be able to break it any further. Is that correct?
Yes, sir.
Good. At that point that you cannot break it any further, it is called indivisible. In the same way, the atomic theory proposed that atoms are indivisible and cannot be created nor destroyed. At that time, it was believed. However, as we progressed in science, we discovered that atoms are actually divisible. In other words, they can be divided. But that one is a story for another day. Okay? So the third um idea of the atomic theory is that atoms of the same element are identical in size and in properties. Now, David, I want you to look at this for me. You can see that the atoms of this gas over here, they are all the same size and they are all the same color. Is that correct?
Yes, sir.
Good. The same thing applies to the liquid over here. All the particles have the same size and the same, everything about them is basically the same. That is what the
Yes,
third
sir.
idea of the atomic theory is saying. Atoms of the same elements are identical. Identical means the same. Just like if I say identical twins, it means they look the same. They are identical in size and identical in properties. And then the fifth one says, or the fourth one says, atoms of different elements are different in size and in properties. So for instance, let's say I have, give me one example of any form of matter you know, David.
Chair.
Chair, good. So let's say I have a chair. The atom of a chair, let's say this is the atom that makes up the chair. Give me another example of any matter you know.
Pencil.
Pencil, okay, very good. If I take one atom from this pencil and I take another atom from the chair, the atom of the pencil is going to be different from the atom of the chair. So just for the sake of illustrating, you can see that the color over here is different from the color over here, right? Hello, David, can you hear me? Hello, David, are you there? Can you hear me? Hello. Can you hear me, David? Okay. It seems David's network is fluctuating a bit. Let's wait a bit for him to return. But while we do that, let's do justice to what I was explaining. My friend, can you hear me? If you can, please let me know.
Yes, sir.
All right, beautiful. By the way, what's your name?
I,
Yes, I'm listening. What's your name? If you can hear
eh,
me,
my name is Dominic.
okay, Dominic, thank you for joining today's class. So I was explaining the concept of atoms being different in size and in properties. Okay, so here is one form of matter, a chair. If you take one atom from a chair, this theory is simply saying that the size, the color, everything about this atom over here will be different from everything about this atom over here. You'd notice with me that the color here is blue and the color here is red. Is that correct?
Yes, sir.
Very good. So those are the four ideas of the atomic theory. And then the final one says atoms combine in simple whole number ratios to form compounds. So here is what we mean. For instance, let's say we have the compound water, which is H2O. What this law or what this idea is simply saying is that there is a simple whole number ratio that is followed before this compound can be produced. And what is that ratio? We have two atoms of hydrogen combining with one atom of oxygen. So this is 2:1. So this law simply says that this is correct because it is combining in a simple whole number ratio, a ratio of 2:1. Did you understand this?
Yes, sir.
Very good. I'm so excited that you're following up with today's class. So now that we've talked about atoms, let's talk about molecules. David, you're welcome back.
Yes, a network problem.
Yeah, I understand. So we talked about what atoms are. Now let's talk about molecules. What are molecules? Yes, Dominic, do you want to tell us?
Yes, sir.
Yes, please. What are molecules?
Molecule,
Don't copy from my screen. No, I want you to
I know,
use
sir.
uh
Molecule is the simplest or the smallest unit of a substance or element that is capable of existing independently.
Thank you. Thank you. Did you know I deliberately decided to hide that definition to test your ingenuity in this class? I said I was not going to include that definition because I didn't want this class to be complex. That is the phrase that I wanted you to mention that can exist independently. That is the word. Independently means
Alone.
independently. Independently means it can exist on its own. Are you there?
Yes, sir.
Beautiful.
Yes, sir.
So here is another definition that definition you gave Dominic is absolutely correct. Okay. Well, for the sake of being very simple, here is another one. Molecules are the products that are obtained or gotten when two or more atoms are chemically joined together. So, for instance, now let's say you have one atom A and then you have another atom B. When this one is joined to this one, and then they produce something called AB. This AB here is what we call a molecule. Why? Because two atoms have been joined together. Are you there?
Yes, sir.
Now, here is a very
Sir.
good
Yes,
example.
sir.
Thank you. Here is a very good example. Water, H2O. You can see that H2O is the combination of some atoms. How many atoms are here? How many atoms are here?
Two.
Are you sure? How about you, David? How many atoms are there? You want to try? Are you sure it's just two atoms?
I think it's three.
Okay, let me turn the question. How many elements are here?
Two.
Okay, now how many atoms are here?
One.
Okay, let's do it. Let's do the challenge now. H2O. If I say how many elements, I have the elements hydrogen over here. Is that correct?
Yes, sir.
That is one. And then I have another element, oxygen here. That makes two elements. So if I say how many elements, I'll say two elements are there. But if I say how many atoms, I have H2O. So for hydrogen, I have two atoms of hydrogen because of these two. Remember, these two belongs to hydrogen, right?
Yes, sir.
Good. So I have two atoms plus. How about oxygen here? How many atoms of oxygen are there?
One.
Good. So how many atoms do I have altogether?
Three.
Good. So if I say how many elements, there are two, hydrogen and oxygen. But when I say how many atoms, that is a different ball game entirely. There are three atoms there. So I just brought that in for effect. Is you understood now?
I said three atoms.
Oh, sorry. I think I misheard you. I thought you said two.
I first said two, then I
Oh,
said three.
okay. It was the two I heard at first. I didn't hear the three. All right, thank you for being correct. Are we cool now?
Okay, sir. Yes, sir.
All right, good. So a very good example of a molecule is the water molecule. The water molecule is made up of two hydrogen atoms and one oxygen atom bonded together. That's why we have H2O. So here are the types of molecules that we have. Number one, we have the diatomic molecule. Can you say that after me, please?
Diatomic molecules.
Thank you very much. Diatomic is
Diatomic
simply
molecule.
the combination of two words, di plus atomic. Let's define all of them individually. Di here is simply a word that means something is two. Are you there?
Yes, sir.
In basic agricultural science, when we're talking about types of plants, do you remember they taught us something called monocotyledon and dicotyledon? Do you remember?
Yes, sir.
Are you sure?
Yes, sir.
Good. So di here means something is two, and then atomic means atoms. So when we say diatomic, we are simply referring to molecules that have two atoms of the same or different elements. So now let's see some examples. When we have a molecule that has two atoms, whether the atoms are the same element or not, as far as the atoms are two, then we call it a diatomic molecule. So example number one is oxygen. We all know oxygen because we're breathing in oxygen right now. Is that correct?
Yes, sir.
Anybody that stops breathing will not be in this class, obviously. So how many atoms of oxygen are here in this molecule? O2.
Uh, two.
Good.
Mm.
It is two because of this subscript over here. You can see there is a small number two under oxygen. Is that correct?
Yes, sir.
Beautiful, beautiful, beautiful. So this definitely is a diatomic molecule. The same thing applies to this hydrogen molecule over here. And then you can see carbon monoxide. Now, David and Dominic, here is what I want you to do. For each of these examples, I want you to tell me for oxygen, how many atoms are there and how many elements are there. For hydrogen, how many atoms are there, how many elements are there. And then for this guy, how many atoms are there and then how many elements are there. Let's go.
Okay. For oxygen,
Yes.
there are one element,
Okay.
two atoms.
Very good. How about for the second one?
For hydrogen, there is one element, two atoms.
Okay. Okay.
Then
Okay.
carbon monoxide is two elements, which is carbon and oxygen,
Yes.
and they both have one atom.
Beautiful. Beautiful. So we have two elements over here, and the number of atoms are also two. Do you
Yes, sir.
agree? Do you agree with that?
Yes, sir.
Beautiful. How about you, Dominic? Do you agree with what we said?
Yes, sir.
All right, that's beautiful. So that means we can proceed. All right, now, so we've seen the first category of molecules that we have, which is the diatomic.
Yes,
And
sir.
then next one we have is, can you see what's on the screen?
Yes, sir.
Okay, what is it?
A tap with water coming out.
No, 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 no. The right up first before the tab.
Oh, for atomic molecules.
Polyatomic molecules. Now, the word polyatomic is simply the combination of two words, poly
For
and atomic.
atomic.
Dominic, when we use the word poly, what do we mean or what are we referring to?
Something more than three.
Okay, something more than, in this case, we're saying more than two, something more than two, because three and above is where we use the word poly. So now when we say polyatomic, we're talking about molecules that contain at least three or more atoms that are joined together. Example number one is
Mm.
water, H2O. How many atoms are contained inside water?
Uh, three.
Okay, how did you know it's three?
Two, two atoms of oxygen and one atom of hydrogen.
Are you sure? Two atoms of oxygen? Let's check it out. How many atoms of hydrogen do we have here? We have
Yeah.
H2. So that tells us that
Uh,
we have
oh,
two
sure.
atoms of,
So the other way.
yes, two atoms of hydrogen. And then oxygen, we have just one atom. So altogether, we have two plus one, which gives us three. So water qualifies to be a polyatomic molecule. And then we have carbon dioxide, the stuff we breathe out when we exhale. How many atoms are here? We have CO2. There are three
Three,
atoms. Yeah, thank you. How many elements are there now?
two.
Good. We have carbon and we have oxygen. And then we have ammonia and glucose. Do you know what glucose is? How many atoms of, how many atoms are inside glucose?
Uh,
Dominic, you want to tell us? How many
24.
atoms, how many atoms are inside glucose?
24.
How about you, Dominic?
24.
24. Beautiful. And if you may be wondering how we got 24, you can see carbon here has 6 atoms, hydrogen has 12 atoms, and oxygen has 6 atoms. When you add 12 plus 6 plus another 6, it ends up giving you 24. So these are some examples,
Mm, okay.
or yes, some examples of polyatomic molecules that we have. So now, this brings us to the next class activity I want us to carry out. Can you state some of the differences between atoms and molecules? David, you state one, and then Dominic, you state one. Let's go.
Okay. Okay. Atoms are the smallest part of an element. Like there's nothing that is smaller than that. And and molecules are mixtures of atoms that can stay independent and can be separated. And can be
Mix
separated.
mixtures there. Mixture is making me to laugh. Mixture of atom. Okay, I'll allow that one to pass for an elementary definition. How about you, Dominic? Do you want to tell me one difference between an atom and a molecule?
Yes, sir.
All right, please go ahead. The floor is yours.
And for atom, it is the smallest indivisible part of an element that is capable of undergoing chemical reaction. While molecule is the smallest unit of an element that can exist independently.
Hmm. Hmm. I like that. I like that. So if I ask this question, in terms of size, between the atom and the molecule, which one is bigger?
Molecule.
How about you, Dominic? Which one is bigger in terms of size? Between the atom and the molecule, which one is bigger?
Molecule.
Very good, very good. So we've dealt with two examples. So here are some examples of the everyday molecules that we interact with. What is the first one?
Oxygen.
Beautiful, beautiful. And then, of course, you know that oxygen is the molecule that we breathe in when we inhale every day. Is that correct? And you can see the application over here. In hospitals, when a person is having trouble with breathing in, they apply something that they call an oxygen mask. Is that correct?
Yes, sir.
Good. And
Yes, sir.
on airplanes, when somebody is taking a flight, when the air hostess or whoever is speaking to the passengers comes on board, the person usually shows you the different things to use in case of an emergency. And one of them is an oxygen mask. Is that correct?
Yes, sir.
So oxygen happens to be one of the molecules that we interact with every day. The second one is none other than water. Water is very essential for life. Now, I've mentioned two molecules that we interact with every day. David, do you want to give me one example?
Oh.
How about you, Dominic? One example of the molecules that we deal with every day. Yes, Dominic. I'm listening. Of all the molecules that we deal with every day, can you give me one example? David, I'm still waiting for you. Hello, can you hear me now? Hello, David. Are you there? Hello. Can you hear me now? Almost. Can you hear me now?
Yes, sir.
Okay, sorry, it was a network fluctuation. So, we're talking about some of the everyday molecules that we deal with in our everyday life. And then the next one is water. Do you want to give me another example?
Yes, sir.
Um,
I said glucose.
okay, glucose. Yes, glucose is actually the next or one of the examples that we're going to be dealing with. Let me move forward a bit. You can see it over here. Glucose is the molecule that is gotten from the food that we eat. So let me show them to you.
So I can't see it.
Yeah, I'm going to share it to you. You see it right now. Should be able to
Yes, sir.
Hello, good afternoon. You're welcome. So can you see it now? Can you see it now?
Yes, sir.
Oh, beautiful. So glucose is one of the molecules that we deal with in our everyday life. You're welcome. Our new Okay, I thought someone new joined. So, carbon dioxide is another example. We utilize carbon dioxide when we breathe in and when we breathe out. And then we've talked about majority. major examples of the molecules that we deal with in our everyday life. In our next class, because we've come to the end of our class for today, we're going to be talking about states of matter. This happens to be one of my favorite concepts in chemistry, and I hope you're looking forward to doing that class with me. Is that correct?
Yes,
Yes,
sir.
sir.
Beautiful, beautiful. So, for now, there is no assignment that I want you
Oh
to
no,
do.
say the name
It
again.
is at the end of the class states of matter. That's when I'm going to drop all the assignments. So I want to say a very big thank you to each and every one of you who stuck around till the end of today's class. Like I said, the recording for the class is going to be dropped in the group. So if anyone didn't catch up, they can just go and watch it and follow through. Thank you very much once again. I hope you enjoyed today's class. Is there any question from anybody?
Yes, sir. Yes, yes, sir. I have a question, sir.
Yes, please ask.
So when you were asking for the difference between molecule and atom,
Yes.
um, my friend David said that there is no other particle that is smaller than atom. And based on my research, I found out that
Yes,
we had other
thank you for pointing that.
subparticles,
Yes, thank you for pointing that out.
plasma,
I forgot to correct him. There are actually other particles that are smaller than the atom.
like the proton, the neutron,
Thank
and
you.
the
And the
electron.
electrons. Very good. Thank you for calling my attention to that. David,
Huh?
yeah, when you were talking about the particle or the properties of an atom, you said it is the smallest. Yes, atoms are very small, but there are other particles that are smaller than it. Okay, that's why we have stuff that is called the subatomic particles. We have the
Okay.
electrons, we have the protons, and we have the neutrons. Thank you very much, Dominic, for calling my attention to that. I forgot to
Yes,
mention
sir.
it. I forgot to mention it. So
Uh,
there are other
sir,
particles smaller. Yes.
you didn't talk about the modification of Dalton atomic theory.
Yes, we're going to talk about that in our next class. I just wanted to
Oh, okay,
lay, yes, I just wanted to lay a ground
sir.
foundation to show you what the Dalton's atomic theory was. In the next class, we're going
Okay,
to
sir.
talk about the modification, what it is
Okay.
presently now.
Yes,
So,
sir.
yes.
And sir, also, I am based on my other research,
Mm-hmm.
about atomicity of molecules. Eh?
Yes. Yes.
Based on the type of atomicity of molecules, we had monoatomic,
Yes.
diatomic,
Yes.
triatomic, and you
Yes.
only you only said that diatomic and polyatomic.
Yes.
You didn't
Yes.
say monoatomic and triatomic.
Yes. One of the reasons why I didn't actually include the monoatomic molecules was for the sake of simplicity. You know, we're just beginning this class. There is actually the monoatomic molecules. Remember, one of the definitions of molecules we
Cannot
said
give back for.
was the
Can
smallest
see that
part
from hand.
of a substance that can exist independently. Now, for example, one of the elements we have on the periodic table are the noble gases, and each of these ones can exist independently, even as a single atom. So they qualify to actually be molecules. So one of the types of molecules are actually the monoatomic molecules. For the sake of the simplicity of this class, I deliberately did not include it so that we can understand the concepts of molecules. Hello, are
Okay,
you
sir.
there?
No problem, sir.
All right. All right. Thank you for drawing my attention to that. It shows that you're following the class in depth and every step of the way. How about you, David? Do you have any question?
No,
Are you sure?
no.
All right. So, Dominic, I'm looking forward to having you in my next class. Okay. Make sure you don't miss it. All right.
Okay, sir. I
I'm,
won't,
yeah.
sir.
Yes. I'm looking forward to having you around. Thank you for joining in once again. I will see you in the next class, which is on Monday. Till then, stay safe and thank you.
Thank you, sir.
Bye.